So let's talk about desktop apps in OTP 24, and it's really bleeding edge what we want to talk here, because it's just coming up with like the newest version of OTP and the newest version of Elixir. And I got a question actually before the talk already, and that really inspired me to look at the goals and at Scenic a bit as well, and talk about that. So there was also like a poll I did before, and I asked people like what operating system you're using. And I'm personally like a Linux user, so I'm always curious like how the distribution is. And like most people are expectedly on macOS, and then there's a few Windows users who I'm really curious about. But I'm even more curious about that one person here who said like he's on a different operating system than those three. So if you were one of those, like I would like to know what that is. Just write that in the chat. I'm going to check it out later. But in terms of writing desktop applications, of course, that's important to know, like, where do you deploy? If you want to create desktop applications, they probably need to run on Windows, because I see like a shift there where more and more creators are actually on macOS, but most of like the user base and the still most used OS is still Windows, right? So macOS seems to be becoming more and more that land of creation. And I'm going to talk a bit about like why that's actually especially good. Maybe I need to change at some point from Linux, but let's go on. So let's start here with the goals of this project. What did I want to achieve, and why did this get open source, and what is it all about? And I just heard Jose talk yesterday about NX a bit, and he used this term owning it, like owning the stack when they write NX, and owning the code and owning that core knowledge. Like you have this core knowledge that you create, and you want to be able to take that into those different areas like machine learning. And it's very similar to me, even though the first term I came up with was code reuse. So I had created a lot of server code already that run on servers in different headless machines on like Linux environments. And then when we're about to create like a desktop client, and starting with like, want like a little taskbar icon, maybe some settings, like it should be know the desktop, but we don't want to rewrite all this code that is like our core competence. We actually want to keep that close to us. We want to own that. How can we own it? Not need to rewrite it, not need to outsource it, but still get to the desktop. So you will see that again, like owning the code, staying in one code base, staying in one language is like a common theme here. Then I really, that's the goal of the project. I want this whole thing to ride with the rising tide. So as we build on top of Phoenix, LiveView, and GetText and Actor, all these cool things that come out of Elixir and the community. And we want to ensure that this is actually things we can leverage, especially the cool web technology, in my opinion, totally cross-pollinates with writing modern desktop apps. And we want not to abstract that, but actually expose that and grow with that. As that gets more features and LiveView is getting better, that writing desktop apps is going to get better. It should be distributable. So this the goal is really to create native apps. Like you, as a Windows user, you get an installer.exe, and you download that, and you double click it, and it installs, and you have like a normal native app. On macOS, you get a DMG or a package file. Same story. Linux Debian, and eventually probably store support. Like there's this Windows Store, there's the macOS App Store, potentially those. Then another important goal is like be a good desktop citizen. So this is not only about like taking the code and running it on all OSs, but actually integrating with that OS. So that means drag and drop, going into having notifications in the notification area, and showing icons in the right places, showing the names in the right places, really be like a good, proper desktop application. And I put out this stretch goal maybe just to put some context in some of the decisions you might see in the API. That's like, it would be really nice at some point to have the same code be able to run on iPhone and Android. And there's like some projects that try to run Beam code there using the Atom VM. If one of you guys is into that or has knowledge about Atom VM or like some of these projects trying to run on these environments, I'm happy to hear about that and talk to you. So reach out. So it's not the first time we're doing desktop apps with Beam. And there's like a couple of them. I picked 3 examples here. The first one, the Observer, is probably that everybody who has worked with Elixir or Erlang knows. It's the Observer. It's part of the standard distribution and helps you to debug applications and really look into that. It's built on top of the WX widgets library that it's bundled with like all Erlang distributions as part of the normal OTP. And is like the first insight into like what you can do like with a native app development. And the second biggest application there for me, or it made the biggest impact, was really Wings 3D, which is done by Dan Gudmundsson. And I want to shout out to him. He's in the OTP team. He has been doing a lot of work to maintain, like to do Wix widgets inside Erlang, but also then to maintain it. And was super helpful when I did the pull requests for the web view that we're going to talk about. But his example of the Wings 3D application really was like that part where I wasn't sure, like, can we actually make it distributable? Can we make like an exe installer for Windows, for macOS? Can we make it native? And that's probably the project that's most mature there. Like he has done that. And you can check out the code. He has done like all the things to actually go to the final installers and including code signatures. So we're going to talk about that a bit. And that's what convinced me like this path can actually work. And so we got down this path with desktops. And then last but not least, there's Scenic, which is from this pictures from 2018, introduced by Björn. And the goal of Scenic is to create these also like apps that have very direct graphical access. And I got this question, how is Elixir Desktop different from Scenic? And when should I choose one versus the other? I think that's a really good question. So we compare here like a bit of the goals of both. I think they're really, really different, but it's good to talk about that. So Scenic has like this goal of being small, fast, and simple. So you can deploy it to even like small IoT devices on like embedded chips. And that's really the non-goal for Elixir Desktop. For Elixir Desktop is like, we want fat HTML apps, like web apps that use LiveView and use all the good stuff that comes out of Phoenix and LiveView and the more like, so that goal of being minimalistic and not having a browser and not having any extra stuff, it's definitely not an Elixir Desktop goal. It's like the opposite of that. But Scenic has this explicit goal of being robust. Like you have gen servers and they fail over and then they restart. Of course, you just want that in a desktop app. Like how bad is it to have a desktop app that crashes and then it's gone and you like, the state is potentially gone. Like maybe your Office document that you were just working on is gone. Like that's terrible. And with Erlang, we get that in Elixir Desktop. Of course, we want that as well. Like who doesn't want that? Scenic has these attributes of being remotable and secure. So again, that is from the IoT background, I believe. So where you have devices in the field, maybe in a truck, maybe in a sensor, and you want to be able to remotely debug them. So that's not the same goal for Elixir Desktop because it does not have this mindset of being like remote, not non-screen system first, but instead it's primarily a desktop app and wants to integrate into the desktop nicely at the place it needs to be. And potentially in terms of security, not even be connected, just be a local application. And that brings us to the next point where they're very similar in Scenic. I found this in the 2018 presentation where he said like, never trust a device if you don't know where it keeps its brain. And I would say like from the decentralized web perspective, there's this term local first. We want to have a local first application. That means that even if you don't have cloud or the cloud is offline, your app locally should work. Like it's so terrible if you open your Notes app, but the Notes app can't access anything because it doesn't have a cloud connection, or your files, you can't reach them because they first need to be synced. So we want to have something that is local first and works offline as well. And so I think they're pretty similar there. Scenic had this nice thing about avoiding the matrix HAL, which I think is really out of experience with like different versions of embedded devices, and you can't upgrade the hardware, and you want to ensure that they stay on certain versions and you can roll out new versions without impacting them. So really going away from the server model, you update the server and all clients have to eat that. Now that's not really an Elixir Desktop goal. I think it's probably rather for me, and like when I set out to do this, a goal to be able to distribute updates into the application really quickly. Like especially if you make a desktop application, updating is so difficult. Like if you ask people like, please update your app, a short percentage of that will do it. But if you can do something like ship them new Beam files under the hood and Erlang is reloading them, that's just awesome. It's using those strengths of Erlang, and that's where we want to go with Elixir Desktop. And then probably one of the, that's actually one of the non-goals of Scenic that was listed. Scenic is not a web browser, and that's probably like one of the easiest differentiators. Elixir Desktop is a web browser. Like that's the primary idea. It's an embedded web browser in which you write your application. And the last one here is a distributable that I mentioned specifically. I'm not sure on the Scenic story there. And maybe, again, like maybe that's something that Scenic and Elixir Desktop have in common. Like the whole packaging into installer files, into DMG files. I guess that can be interesting for Scenic as well. So maybe there's a path to cooperate or like do something together in those projects. That would be awesome. So thanks for that question. That really made me think about that. That was Adi who pushed it. So this is a little overview of like how Elixir Desktop works and where it sits. So we have your LiveView application, and really works like it would today as a normal web application. You use Acto, you use Phoenix LiveView, and you use Erlang. And now what you do in addition, you get some additional tools in Elixir Desktop to actually show a window, show notifications, show a taskbar icon. But what I want to highlight here is that you don't have to talk to WX widgets directly. So there's a lot of cumbersome, I would say, like previous generation UI logic, like you build procedural buttons, like build this button, then build another button, then add like an event handler. WX widgets works like all the old UI libraries that like Windows native or GTK native or like even old macOS APIs would do. So it's very procedural, and we don't want to touch that. Like, so Elixir Desktop helps you not touching WX widgets, but instead gives you easy access to what you need to be a good desktop citizen, and otherwise wraps your web application. So you can do declarative working with your web view, and even declaratively define like application menus. Now under the hood, under Erlang even, so you're not going to touch that with your app directly, this is being driven in the different operating systems with different embedded drivers for the web view. So on Linux, it's WebKit GTK. macOS has its own native WK web view. And on Windows, it's Edge-based web view too. So they're all WebKit based. So that means your app will most likely look nearly the same. There's still like small version differences. Sometimes you have to watch out for, but they will look nearly the same. And it's like the most native thing you have at the moment, which means for macOS, for example, specifically, we don't have to ship a browser because it's using that system embedded browser. And this is really like where we want to go with this. Like applications that are based on web technology are more and more common, and they are the new standard. So in the background, you see, of course, Slack here and Discord, but there's also Microsoft Teams. And Microsoft actually announced that they're going to do like a lot of their new application development only with web technologies. And this is like what we're jumping on. We're going directly to that next level of application development, where it's web-based, web technology-based, and you have full control over all the layout, and it's not operating system specific anymore. This is like an issue that has become or is really real. And sometimes when you double with it, or when you just use brew to run your Elixir application, something you don't realize. But if you actually ship an application out there into the wild and you give it to users, in macOS and also in Windows, these are actually now walled gardens. And you've got to, once you have compiled everything together, you've got to sign that. And that's definitely the part we want to cover. Right now, it's still manual. Like you can package it, you can create a mixed release, but then the signing of that is like really important on your road to deploying it. And this is how it looks like. Of course, you develop, and I've done now here in Violet, you see those things that are working today, and you get them covered. So you can develop, you can see that locally, that's all like a normal Elixir application, and we can look at that in a moment. Then you can do the mixed release, you get like the package that is including nearly all the binaries you need. There's still like a bit of dependencies on the OS, like on macOS, you want to have an icon, you probably want to have some associations that need to be part of the release. Then there's the bundling. So DMG, Axe installer, make self, or a Debian package. Then there's this signing, and I just mentioned that on macOS now with Big Sur, you have to notarize an application, which means not only you sign it, but you send it to Apple, and they register that it's from you, they notarize it, and they send it, they give you an okay then. If you don't do that, it's like you cannot distribute an app. And it's quasi-mandatory on Windows as well, because otherwise you often get like positively identified as a virus, even if you're not. And then like people get stuck into this screen where it says like Windows protected to your PC, and you have like no option to go anywhere. But all of that can actually be automated. Right now, it's like partially documented. Some of that you find in Wings 3D, but this is really like down the road where I want to get to with Elixir Desktop. And then there's like this other part of what do you do once you have got it installed on your users' desktop machines? How do you go from there? How do you update it? And there's basically two paths. There's like the path where you said, like, I know like Erlang is based on .beam files and Elixir as well, and I can just update them. I don't need to resign all the binaries, like the beam.smp file. I don't need to resign that. And as long as you don't have a lot of NIFs that you update, like if you don't have any NIFs that you need to update, that's actually a path where you can just auto update, skipping the signing step, and directly ship out there. Otherwise, you have to go again through the OS packaging, or maybe like if you support like a store, that path. So this is like the story of it. I want to show a little bit of how this actually looks like. And so I'm gonna start here with the to-do app. So there's a GitHub repository. I'm gonna link it. And that's a little to-do app that I've created just to see what this does. Where we're starting here is out like, this is a pretty normal LiveView Elixir app. Actually, I created it from the skeleton creator from Phoenix, and then there's this couple of small additions to turn this into a natively looking application. The first thing is we start this desktop window. So the desktop window is like a child we add to our supervisor hierarchy at the top, and we define a couple of items here. This is our application name. This is actually the app name in OTP. We have an ID for our window, a title that we show at the top, the initial size, an icon. We want to show like a little icon. And then we define here two children of this. We want to have a menu bar, and we want to have an icon menu. And finally, we pass it an URL. That's the initial URL it should go to. So that's like from our normal like Phoenix web application, the endpoint URL. So just to show that, I'm gonna make this window smaller here. And we're gonna run this application here. And here is our little to-do application. So it comes up, it's a window. We have up here, if I click this, there is a menu. And so that is what we actually passed in the icon menu down here. It's similar to a LiveView, just that it's a menu being rendered up here, like as a native OS menu. And the menu bar that we have been passing here is also similar to a LiveView, just that it's being rendered as a menu up here. So this is natively supported. And if you run it on macOS, obviously that appears as a menu bar in the macOS menu. Now, this application, we could tell it like we don't actually want this to pop up the window immediately. Maybe we want to start this window in the background. So we say like hidden true, just start this again. So the application is up, but it this time did not pop up the window. Now I need to go up here and say open. And there is still the same app. And to go into like some of that, what we done here to really make it all declarative and get away from like this old usage of procedural generation of UIs. Let's look at the menu. So we got this menu bar up here that we can edit. And so this looks pretty much like an Elixir LiveView application. I hope this screen is actually big enough. I don't know if I have to increase the font size. If yes, please speak up. So we have the to-do menu bar. We're using getText here, so that's just standard tools. Then we use a desktop.menu. So that is similar to how you would use like LiveView, but because this is like a native UI menu, we're using the desktop tool. And then in our render function, we actually draw these menu items here. So we have two items below here. We can see them actually in the bar. We have file and extra. So there is extra menu and there's a file menu. And then it's the same that we actually get rendered here. Now, the cool thing with that is that because of the way we use LiveView in our apps and the fact that we reuse all of that technology, we also get access to PubSub and Actor repos. And so that means in my little to-do app, if I add like, or if I change this, like my prepare slides is done, now it's not done. And I go up here and check, like there's like a little tick here and I can see that. I can tick it also there. It's all being synchronized. So it's synchronized here, going live, and I do it here. And it's done in the very same way you would create it in a LiveView. So we have this handle event that's triggered by menu items. And we also have the handle info when something changed, and then we reload all the to-dos. And we get this handle info changed every time we get like an event from our to-do repo, which is an actor repo. And I can jump here, which is just subscribing to a Phoenix PubSub. So again, rising the tide of all of that infrastructure, but having added here the layers to make a native menu bar look like it's a LiveView, and have you added that without needing to know anything about like all this desktop fuss. So I can of course change that here as well. Like right now it says like show the observer or show notification, open browser. Maybe I just want to shortcut that and say like this is just like that. Now it's going to reload that. I need to trigger like a change. So I'm going to trigger a change here in the menu, and then we see like notification observer browser. That's exactly what I've done here. So just showing that this is what we're doing here. Also, because this is a web app, of course, we can still leverage all the good stuff that we have in terms of CSS debugging. And so someone had like this really bad idea of making the check mark here in white, which means like we actually can't see it here. So we want to change this, but it's sometimes difficult to figure out just from looking at the native view. We want these browser inspection tools and use those to work on our app. So I opened the browser here. I changed the text back to the full length. And that pops up now, this in Firefox in my case, because that's my default browser. And I can inspect that. And then I see, well, why is this white? There's a marker that that marker is before. I see it has a white style. Border color is white here. Probably we just need to remove the border color, then it would be better. That's cool. So let's check that out. Now we know where it is, what we need to change. Go to the SCSS file. I want to just make this a little bit smaller so we can see it. And then as we update this, remove the border color. Of course, this updates. This is all LiveView. This is all still like auto updating when you develop, and we get this live updated. So this is like a new way to develop this kind of apps. We can also do notifications on the desktop. So there's like an extra, just show a notification. And up here it says, hey, this is my sample desktop Elixir app. And I can click that and it says, well, you did just click on me, you did dismiss me. And that's also handled in the menu bar that we just saw. So we want to look at that real quick. So we have got this on-click item, and it says notification. And then once this is being clicked, it goes similar to how LiveView works to a handle event with a notification. And then in the handle event notification, it uses the desktop.window module to show a notification that belongs to the to-do window. And this is the notification text, sample Elixir Desktop app. And it has a callback when it's being clicked. It should call this callback. And that just confirms you just clicked my previous message. And it has like a type of a warning. So that's actually what we saw. I can just do that again, like click this here, show a notification. And then I click this and now it's red because here it says like that should be a notification. So this is working with the menus. Now I wanted to real quick show like how the supervision works here, because this is again working all within a supervision tree. And if you just open the observer here, then we can see this in our application, that this is pretty much a normal Elixir LiveView app, but down here we have a new entry, which is our to-do window. So that's the thing that we just added to our supervision tree in the start shell. And that has right now two items. It has a menu and the menu bar, which is this up here, and the one that is just in front of our application window. And they're being supervised. So if there's a bug, they're being restarted. It's not crashing your application. It's just crashing those. And they are linked to PubSub because they're actually listening to those notifications when anything changes. So last but not least, again, because we build on the shoulders of giants here, we have also, like I showed that a bit, get text support. The difference is if you do get text on a server, then usually you want to translate your application to like someone on the other side in a browser who's actually asking your server. And so like on per request, you have to check like what's the language I should deliver. But on a desktop app, we want to by default use the language that is actually the locally running OS. So we show the application in the OS language. So when we start up here in our to-do app, we actually ask the desktop library to identify the default locale and set that to our getText module. That's what we do here. And so I can actually simulate that because on Linux, the way you specify the language or the way applications find out the language is like through an environment variable. So if I now say like my language is actually German and then run this again. You see, I'm still hiding the main window here. So let's not do that. Let's actually have it just because it's nicer when we see it directly. Start it up again. And here's our main window. Now it's not the to-do app, but it's the Aufgaben app. And we have everything longer in German, because in German, everything is longer than in English. But we get the translations done here. Of course, these are content items here, my to-do items, so I can like translate to more languages. And then I have a new to-do item. I can tick that, unmark that. They work as well. I want to make also like a short mention here that there's this really good work on the Ecto driver for SQLite. And so this is what we're using here. So we're using Ecto, but we're using a local database because we don't want to, like on a desktop, usually we don't have PostgreSQL running and we don't want to ship it with the app. And so we have this local database that we're using here. We're telling it like, please, application put env, please use this database file. So we're not doing it as configuration because this is a runtime check where we actually try to figure out what's your home directory. That's like the config directory, and put into the home directory a subdirectory to do for our to-do app. And there we put like the database file. And that, again, you can customize as you want. You can store your files, but the to-do app is storing it persistently locally on your machine in an SQLite database. And we have a standard repo that is part of the app as well. Cool. Let's jump back here to the presentation. Because we're through. We looked at that. Again, this works, of course, on all the platforms, but it's quite tedious right now to build it everywhere just because this is so fresh. And unfortunately, if you check out now the package managers, right, you will not have those most recent versions yet there. So this, to get all of this working, you need like a really recent version of WX widgets, which is 3.1.15. It has fixed a lot of things for macOS. It actually looks like really good now on macOS. If you use the older version, it doesn't look so well, but it's just 1 month old. So you don't get it from Brew by default. You have to fetch like a special branch. Erlang 24 is the same story. Elixir 1.12 is the same story. They're also fresh. You don't get them, but I've put like together a guide how you can still compile them if you're willing to go through the adventure, and then you can run this. But this will get easier automatically as things mature and they get into the standard packages. All of this is now public. There's a GitHub repo. Feel free to check it out. It's MIT license. It runs on Windows, Linux, macOS. It actually runs, I mean, Linux, it actually runs on Raspberry Pis as well, because for my application, that's the target. The APIs will likely still break. I would wish to be able to say like all is final and done and dusted, but it's probably not. And if you see things that you think like they could be rearranged, let me know. I'm really open to anyone who's willing to contribute. I'm actually really happy about that. And as I said, packaging bundling, that's something that I want to get into the library, potentially not into the desktop, but into like desktop packaging as a different project, because I imagine it might be useful for other projects as well who want just to do packaging and create installers in the Elixir space. Cool. And check it out. This is a link to the sample app, and go from there. Yeah, that's it. I forgot to mention, we are actually hiring. So if this sounded interesting to you and you're into like decentralized applications and peer-to-peer applications and owning your data, check out Diet. I also make the job post in the Vuva app, and let us know. Otherwise, I'm happy to answer any kind of questions if you still have time left.
Great. Yeah. Thank you, Dominic. We do still have a couple minutes. I mean, you touched on Adi's question already, but there is another question from Dimitri. Dimitri, if you want, you can unmute yourself and ask, or I can ask for you. I guess if I don't hear anything in a minute, then I'll do the asking, but go for it if you'd like.
Hi. I think the question was already answered in the presentation too, so
okay.
I don't think there is need. Thank you.
Yeah. Okay, cool. Well, does anybody else have any other questions? We have a moment. I want to say I love the notifications. That's like real desktop notifications. It's a hard thing to do, and that's a really cool part of that library. So good work on that. Okay, looks like we have another question from Simon. Simon, feel free to unmute yourself and ask if you like.
Yeah, it's just a quick consideration about security. I'm not sure if you can disable it, but if you can, then I guess that's by default in this case. Assuming you don't want your desktop app to be able to be connected to something else locally.
You mean the security of? There's for sure like one security consideration that that I didn't talk about that the library does here, and that is when you can actually see that when I click here on extras, and this is German now, but if I open this in a browser, because this is locally opening effectively a browser app, there is a TCP socket open where this is running on, right? This is on localhost. And we want to ensure that this is not being used by a random application. And so there's some authentication token here that the app is internally using. And so if you have like some random app, maybe even or an app from the internet trying to like test localhost, they will always get like a non-authenticated error message. So unless you have access to this token, which only the app has, you cannot just talk to that web server that is running in the background. I'm not sure if that was a question, but there's of course like, I mean, there's probably like another security aspect to it, and that is when I was starting out this, I was first like thinking, oh, I just need this icon. So I created like a C++ Qt application, and it showed like this icon. And then I realized two things. One is I can't reuse all my libraries I've written in Elixir already, right? And if I have a bug in my C code, that not only crashes the app, but that's a security issue. That's a security issue. Like a buffer overflow means like people can take over the desktop in the worst case. And that's something that Erlang with the VM just protects you again. Like if you have a bug in your application and that crashes, it is a crash inside the application, but it does not create like a buffer overflow that is usable to like take over your PC. I think that's a big plus in terms of security. I don't know if that answered your question though.
I meant specifically the cookie for connecting to different Beam nodes. So to disable that feature, because you wouldn't want to have your application running and being open to connections, I assume. Yeah,
exactly. That's a good question. There's a bit more like, this is about when you package and deliver the application. And that's definitely like one thing. I think there's certain use cases where you want the application to connect to other nodes and you want EPMD running. But in the most cases, you just don't need EPMD and you just don't need distribution. Because even like running the observer, if we start the observer from within the app, it does not require node-to-node communication because it's running inside your same node. So it's just disable it for deploying it. Yeah, that's the best. And then like it's not like you disable node-to-node communication. There is not even a cookie because the ports are just closed. Like there's no way to get to it. It also.
Great. Oh, go for it.
Just one more on that. Sorry, but there's like there was a post I think 3 days ago on like how do you when you update an Erlang application or an Elixir application at runtime, you sometimes get these conflicts where it says like I can't replace this file, I can't update this file because it's already running. And also their EPMD is actually a problem because EPMD, even if you stop your application, EPMD, which is the daemon that facilitates the node-to-node communication, keeps running in the background in terms like any other node is still running. And then that will block your update and users will see this error message, especially on Windows, where it says like, I can't install this application because I can't replace this file and people are thrown out. So just disable that, don't deliver even EPMD to the desktop with the desktop installer and you're good to go.